All right, this time, instead of being given a graph or an equation, we have this table. We're actually going to skip A. I don't know why I threw that on there. We haven't covered that yet, so just scribble out A for right now. We're just going to do B for this one. At what time indicated in the table? It's essentially multiple choice. There's only 4 times indicated in the table, 0, 2, 6, and 10. Those are your choices. So if you lose your mind, guess something, all right? At what time out of those 4 is the speed decreasing? Which one do you think? If you had to guess, at which one? 2 is the right answer. Why is it 2? Yeah, okay, so let's talk about that real quick. If you say they or it on the AP exam, they will not give it to you. You have to say velocity and acceleration. I am kind of on their side on that one. You have to say the thing. You can't just say it or they. They don't know what you're talking about, okay? So at what time indicated in the table? We would say time 2 because velocity and acceleration are what? Yeah, I would stick with opposite. Opposite signs there. But that's it. And you have to say signs. If you just say opposite, they won't give that to you. No, that's actually better. I was being lazy. Oh, personal preference. Yours is actually, that would be like the fancy way. I went the lazy route. Oh, yeah, then write out the word. Yeah, and if you like, because when you take the test, you're going to be nervous and anxious and stressed, just write it, whatever makes you feel calm. All right, last one. A car is traveling on a straight road from 0 to 24 seconds. What did they give us? Good job. Velocity. What are our units? Meters per second. Do you see how it's something per something else? Now they throw this piecewise linear at you. You don't need that. Piecewise means it's broken into pieces. Linear means lines. Do you see how it's lines? Oh, there is 2 that. All right. For each of derivative at 4 and derivative at 20, find it or explain why it doesn't exist. All right, let's look at v prime of 4. I'm going to point to 4. It's right here. Just use your common sense, fall back on your instincts. Do you think there's an answer or not at 4 for a derivative? Right. Do you think we can get an answer there? We cannot because of sharp edge. Confidence. There you go. Sharp edge. So we're going to say does not exist. And then you have to use limits to explain it. It's a limit from the left and limit from the right. This is back from unit 2. I'm throwing a review question at you. Limit as x goes to 4 from the left. Limit as x goes to 4 from the right. And you're going to write the exact same thing under both of them. Normally, I would try to pull it out from you, but I get that we're all tired and this was a while ago. It's v of t minus v of 4 over t minus 4. Do you see how that looks like a slope? It's because it is. It's redundant, I know, but anyone can write the same thing twice. That's my pep talk. You can do it. I believe in you. It's not hard, it's just annoying. And one more thing to remember. But it means slope. That's all it means is slope. So looking at 4 from the left, what is the slope of this section? 5. Why is it 5? That's correct. Up 20 over 4. You could write 20 over 4. That's valid. All right, and from the right, what's the slope here? 0. And those don't equal each other, so you can't get it. All right, what was the other one we had to do? V prime of 20. Derivative at 20. 20 is right here. Do you see where I'm pointing? We can get an answer for that. What's the slope of this section? Think about it. You can't just shout out the answer right away. Like, it's going to be negative, first of all, 'cause it's going down. What does it go down 20 and then over how much? 8? We'll reduce that. What does that reduce to? Negative 5 over 2. All right, B. Let A of t be the acceleration in meters per second or meters per second squared. Write a piecewise function for A of t. So how many pieces do you think are going to be in the function? Again, fall back on your instincts because you do have them. How many pieces are there? 3. Good job. What did we say? And we actually already did all of it. What did we say was our slope for the first section? 5. And that's from when to when? 0 to 4. And then what's the slope for the next section? 0. And that's from when to when? 4 to 16. And then what we say was the slope for the last section? Yeah, -5/2, and that's from 16 to 24. I'm expecting a question. I want to see if anyone's thinking of the same question as me. Go ahead. Yes, thank you. That was the question I was hoping to get at. The reason that there aren't any the reason none of them have an equal to is these were sharp edges and you cannot get a derivative there, so they don't count. And then we're allowed to leave off endpoints, so I just don't put any equal to on any of them. Yeah. Oh, yeah. Oh, right here. So the slope of this section right here, it went down 20 over 8. So it was down 20 over 8. And then you could leave it -20 over 8. That's totally valid. I just reduced the fraction. All right, last one. Average rate of change is regular old slope. That means we need 2 points. Do not be too proud to write them out. We want to go from 8 to 20. So can you grab those points from the graph? From 8 to 20. What is our point at 8? I guess let's do them one at a time. 8 gives you what? Weirdly 20. Do you see that there? 8.8 to 20. I kind of wish it was a different number because that's sort of annoying. And then what does 20 give you? 10? And then slope them. Set it up for me. What will our slope be? 10 minus 20 over. And what are you going to do to that? Nothing, but we do need units. Velocity was meters per second. We did a slope of that. So meters per